Good morning, everyone. So today I want to show uh, mm, some figure um, of canal irrigation. Okay, canal bed regulation escapes, uh, types of canal drop or fall. Okay, so this is a typical location of providing canal drop or fall, where you can provide a canal fall. So this is the water level, canal water level, and this here is the location of canal. This is the drop, location of canal drop or fall is this one. This slope, natural ground surface level along canal alignment, canal bed level is this one, and this level is the location of canal drop. So this is the canal drop, this part. Okay. So as we have discussed, we have different types of falls, isn't it? So these are the falls which made up of lime or rubble masonry. This is a mass concrete. Number A, figure A is oogie type fall, made which is made up of rubble masonry. And figure B, this is the same type fall but made up of concrete and equipped with a stealing basin of energy dissipation. That means here hydraulic jump is formed. Okay. Just one. And this is the figure of a rapid fall, made of a rapid fall and water surface, which is generally situated along a steep slope. And a rapid fall was tried in some of the North Indian canals, which are constructed with boulders cemented together by lime concrete. These were quite effective, but cost being prohibitive was gradually phased out. And the trapezoidal nose fall, that means this cross section is trapezoidal. in shape. I think I have not shared these notes with you. Am I? I didn't share, isn't it? So this note is
No,
also
ma'am.
very important. Next, fall with vertical drop. So this figure generally shows a fall with a vertical drop. Vertical drop fall. And longitudinal section, this is the Sarda type fall. This is the cross section of Sarda type fall. These are the typical cross section of a Sarda type fall. The shape is rectangular and trapezoidal, respectively. These are the speed entrance section. Planar section of baffle apron drop. These are the glacis type fall may be classified. One is flumed or unflumed, and another is meter or non-meter. These are the two fall, glacis type fall. One is flumed or unflumed, and next one is meter or non-meter. A flumed glacis fall would fall with B being less than canal width. Okay. And now in figure B, unflumed glacis where B is same with canal width. Canal regulators. So generally, this figure represents the canal regulators. Location of canal regulator. Sorry, regulator. So in this figure, the cross regulators are showing uh, where is the parent canal is going, where is the head regulator is situated, and cross regulator is situated. Okay, so already we have discussed about these things. Already we have discussed. I just want to show you the figures because it in these notes the figures are showing clearly. That's right. So that is in this figure it is showing distributory head regulator and parent canal cross regulator showing combination with glacis fall and bridge. This is a cross sectional view of a regulator. Okay. Alignment of off-taking canal from a parent canal. Next one is sill bands. What is sill bands? These are thin vertical curved parallel wall structures constructed of plain or reinforced concrete on the floor of the parent canal, just upstream of the off-taking canal. The height of the vents may be about one-fourth to one-third of the depth of flow. Sill vents for diverting sediment bed load of parent canal away from off-take. So generally they are given. Sill vents are provided to divert the silt sediment load, which is carrying by the water from the canal. This is the view of a Gryon wall of taking canal, parent canal, and this way downstream parent canal. Skimming platform. A skimming platform is an RCC slab resting on a low height piers on the bed of parent canal and in front of taking canal and in front of taking canal as shown in the figure. Next, yes, escapes. So we have already discussed water escapes. This is canal bed level. Stone pitching is there. Apron. This is the canal. And this is the crest above bed level. This is the sluice escape. So diesel gets escaped with very low crest height, hence this sluice can empty the canal much below its full supply level. In some cases, these escapes act as covering sluice to facilitate removal of sediment. What is this is all about? Next, let me share a notch. So last class we are discussing about modernization techniques, isn't it? How irrigation can be improved with better quality, with better skill, better renovation ideas, re-engineering. Okay, so why we need the framework of modernization? These things we have discussed. Obstacles in the way of modernization. There may be technical gaps. There may be financial constraint. There may be social constraint, institutional constraint, isn't it? Model for modern irrigation enterprise. So it is clear for many that the irrigation sector in general has not reached the same level of effectiveness as other sectors, such as the industrial and service sectors. Hence, modernization can be seen as a means to create and favor modern irrigation enterprises by introducing methodologies which have proved successful in other sectors. So modernization is a never-ending process of adapting activities to current constraint, and it is still going on. And objectives. The agricultural and economic context are permanently evolving, and some of the demands of society. So low cost technologies. What are the low cost technologies? The introduction of low cost technologies, which could be the part of moderation of small scale irrigation projects. So there may be some where in small village there may be some small scale irrigation project. So for that we require low cost technologies, which provides another example of site specificity of success. Inexpensive treadle palms have been successful in some other. Okay, these palms have been allowed poor farmers. So there are some treadle palms which is used in some countries, which allows poor farmers to make good use of available labor in their households and to increase crop production and farm income. The farmer has full control over the timing and amount of this pumped water, which given the effort involved in used sparingly. Suppose the area under irrigation by treadle palm in West Bengal in India varies between 0.033 to 0.13. Treadle palms have been introduced in Africa, including the urban and peri-urban areas of Tasmania. Here, the vegetable growers rejected the palms in favor of mechanical palms because they could not afford the cost of fuel and spare parts. They could not buy the trill palm. Okay, so bucket drip irrigation kits. What is that? Positive experience have been reported with the introduction of bucket drip irrigation kits. These kits are suitable for the irrigation of small plots of vegetables and fruit trees in peri-urban areas. In Kenya, the return of investment about USS $15 for one bucket drip irrigation kit was about even per month. Okay. So farmers in Kenya have bought about 10,000 kits. I don't know it is applicable in India or not. I think we have not applied these techniques. Rehabilitation, the renovation of a scheme to meet original design criteria. So maintenance activities in reservoir itself comprise controlling aquatic weeds, removing large debris. That means tree trunks floating in the water which may damage hydraulic works, monitoring the water quality, not only from the salt content point of view but also from a biological standpoint, surveying the solid deposition of the bottom of a reservoir, the retention in good working order of open drains includes the following operation: light deforestation, weed control in canal section, seeding grass in canal section, maintenance of low gauges and other measuring device, removal of silt, maintenance of pumping station where water cannot be evaluated. Optimization of water. How can use improve the water efficiency? Water efficiency of irrigation can be improved by crop selection, irrigation scheduling, irrigation methods, source of water. Okay. So improving irrigation practice can be reduce water and pumping costs, reduce cost of fertilizers and other agricultural chemicals, maintain a higher soil quality, increase crop yield. Irrigation scheduling helps estimate the reduced instances which are too little or too much water. Good irrigation scheduling requires knowledge of crop water demand at different cycles, moisture content of soil and soil water capacity. I think you have got what is moisture content, soil water capacity, isn't it? Weather condition, soil capacity, and climate condition, and ultimately accurate methods. Irrigation methods also we have already studied this thing: surface irrigation, sprinkler irrigation, deep irrigation. Method of reducing evaporation loss. How you can reduce the evaporation loss in a canal. The reservoir should be constructed of surface area, less surface area and more depth. Tall trees should be grown in the windward side of the reservoir. Okay. And waterlogging. There may be in waterlogging in any agricultural land, isn't it? And when the root zone of crops get saturated with the subsoil water, the air circulation with the soil pore gets totally stopped. When the soil pores within the root zone of crops get saturated with the subsoil water. See, we have studied different zones of water, isn't it? This is the suppose this is the ground. This is there are surface water in the ground, isn't it? And below this there are some water tables. So if water table rises and also this sub water becomes equal to the water table, then the water gets the crop gets that land is called waterlogging. Okay. In agricultural land, when the soil pores within the root zone of crops get saturated with the subsoil water, the air circulation within the pores will get stopped, so there will be no air gap because all these uh, places around the crops is waterlogged. So there is no soil pores to pass out the water. The waterlogging affects the soil affects Waterlogging makes the soil alkaline in character and the fertility of the land is totally destroyed, and the yield of crop is reduced. Effects of waterlogging. So, what may be the effects of waterlogging? Stabilization of soil, lack of aeration, fall of soil temperature, growth of weeds and aquatic plants, disease of crops, difficulty in cultivation, and restriction of growth. Method of using control. There are some methods by which we can prevent waterlogging. These are prevention of percolation from canals, control of intensity of irrigation, economical use of water, fixing of crop pattern, providing a drainage system, improvement of natural drainage, pumping of water ground, construction of sump well. Okay, so let's stop together here for today. So today, over the present student, Amit Parang, are you present? Pranay Chakraborty, absent. Okay, then thank you.